In this question, we want to look at all of the possible teams that can be formed and what are their probabilities. So this might seem like an unimportant question right now, but this is actually an important little bit of foreshadowing into some of the ideas that we're going to need to explore. So what are the possibilities? So let's look at the number of teens and the number of adults. Okay, well the minimum number of teens you can have is 0. That means that you would have to have all adults. You could similarly have 1 teen and 3 adults. Now this is all for the starting lineup. You could have 2 teens and you could have 2 adults. Well, this is really all the possibilities. After all, you can't have more teens, though you could have fewer adults, but if you had fewer than 2 adults, then you wouldn't have enough teens to be able to make the starting lineup of 4. Okay, so if we have, we already determined this one here. We knew that this was the number of ways that this could happen was if we chose from the group of 4 adults we chose 2 times from the group of 2 teens we chose 2. This product came out to be 6. The total, the probability, well, that was 6 out of 15. So there's a 6/15 chance that you would get a team of 2 teens and 2 adults. Similarly, okay, if we apply the same principle, now from the group of teens, we only want to choose 1. Now we know there are 2 ways to do that. Either we get teen 1 or we get teen 2. From the group of 4 adults, this means that we want to choose 3 adults. So we could set up a similar type of little diagram to look at all the possible combinations, but that might be a little bit more tedious than a little bit more work than we might want to go into right now. So if we do 4 and we select 3 times from the group of 2 teens we select 1, there are 8 ways in which this can be done. 8 total ways. Well, that represents 8/15. There's an 8/15 probability that you get 3 adults and only 1 teen, which should be a little bit higher because the likelihood that you get both teens just by random chance, that's a pretty small group. So to be selecting both of the people out of that group, you probably wouldn't. That probably wouldn't be in our favor if we were just randomly picking people. Now to get 0 teens, so that means from the group of 2 teens, I'm going to choose 0 of them. Well, if you choose 0 teens from a group of 2, there's actually only one way you can do that, right? You don't do it. You don't select any teens from the group of 2. So that really does count as one way. And from the group of 4 adults, you're going to choose 4 adults. Now, before, when we calculated this, we just did 4 choose 4. We didn't do the 2 choose 0. But just so you can see the pattern, if we do 4 math choose 4 times 2 math choose 0, you're going to get 1. Well, there's only one way to select 4 people from 4 people, and there's only one way to select 0 people from 2 people. So there's only one way in which this could happen. So there's only a 1/15 chance that you get all adults and no teens. That's not a very likely event either. But look at all these probabilities. Because we've listed out the entire sample space of possible outcomes, this means that we have figured out basically 100% of all the possible outcomes, and they're weighted in this way. There's only a 1/15 chance you get that, 8/15 chance you get that, and 6/15 chance you get that. We haven't excluded any other possibility. Now, we don't exactly know who's in each of these groups of 8, but that's not important. We could go back and do that if we wanted to. Right now, we know all the possible outcomes and how likely they are to happen. So this is what we've come up here with. What we've come up with here is called a probability distribution. We know where all our probabilities are distributed in terms of all the possible events that could take place.